Okay, hi everyone. We are in the OpenBuild Starnet Bootcamp. This time we are in the session 4, lesson 4. So we're gonna talk a bit. We're gonna talk about testing our smart contract. Remember before we already talked about smart contracts here. Actually, on the lesson number 2 and 3, we deploy it. We play with Remix, Starly, Katana, Testnet. Now this time we're gonna talk about testing, how it goes. Remember also you have all the info on the GitHub, OpenBuild GitHub, that you can check here as well. So let's start. We're gonna talk about testing in general, and then we're gonna go to the coding session. Like I said, already work with smart contract with Remix, Cairo, Starlink, Katana, Testnet, with Goerli, and now we are on the testing. We're gonna talk about how is testing in Web3, what is upgradable smart contract, different types of tests, a bit of local devnets, and snFoundry. That is going to be our main tool for this session. And then the live coding. When we talk about testing, most of the time, when you do the software development, you do this, move fast and break things. Yeah, it's going to work most of the time, but not really on Web3. Sometimes we have this thinking like a test like a NASA, no room for errors. But if we are beginners, so it's not possible to achieve this. We also have this one. Once deployed, it can't be fixed. So it cannot be fixed. It depends. Depends if we have variable smart contract or not. Let's see about it. Web3 is highly adversarial. So it means there are a lot of hackers or attackers that they want to exploit some bugs, and some protocols can lose a lot of money because of what? Because even a small bug, they can, get a huge impact on their business. So it can be catastrophic. So the idea is defense coding, rigorous testing, and call out all of these before to deploy. Yeah, what are upgradable smart contract? So actually it means that your smart contract, once it has been deployed, you can upgrade some functionality. Depends how did you set up your smart contract before to deploy. So most of the time, yeah, it's okay. It's really okay on testnet, but on mainnet is not. Most of the people they don't suggest to do it unless there are some special circumstances, special cases when you can do this. But most of the time, try to avoid upgradable smart contract. Now we're going to talk about automated tests. We have different kinds of tests. The basic one, the unit test, integration test, and end-to-end test. So the idea to unit test is to test just a public or a private function there. So for this, we have to mock some dependencies. For integration test, now we have the public interface only. So we test with the public interface, we simulate the function. Also, we try to emulate the sequence. And end-to-end is going to include the UI user interface and mimics the user behavior. Here is the way individual functions. We can use unit test. If we are done with this, we can do the integration test with a public interface. At the end, we can go for the end-to-end test. So actually, in Cairo and in Starnet, we can use the Starnet Foundry to build a unit test, integration test, and also the Cairo test itself. On this lesson, we're gonna show the example with these two tools. For end-to-end, they offer the Cypress and API. So on unit test, it's gonna be individual function. So it's a white box. It means you can check everything inside the function, inside the test. But for integration test, we're gonna work only with the public interface. So it's gonna be like a black box, only with inputs and outputs. We cannot see what's in the middle of the process. So that's the idea of the test. So it means for unit test, you need less amount of time, speed as well. But if you want to, go for end-to-end test, you don't need really huge amount of time. That is, it's gonna be slow. But if you finish this, you're gonna get you're gonna get a lot of value on your project when you can cover most of the tests with the end-to-end. Yeah, there are more tests for manual testing to test with the UI for quality assurance, fuzzy tests, where you can input a lot of range. A range of input parameters. So the idea is that your function is going to handle a lot of unexpected values, check what is the behavior of this. So it's one is really interesting. And then we have the fourth test, formal verification test. We're not going to talk much about it. Just the previous one is going to be enough. Integration test, unit test. Here we also have the local DevNet. Like before, do you remember if you use Katana structure or the architecture is something like this? You had your DevNet in your local laptop, with the ATP, with the JSON gRPC, this is the URL, sequencer, the user accounts, already pre-deployed, already seeded with some founded, with some money there, as smart contract and the universal deployer. For this one, we have, like we mentioned, a Katana. It's built by the Dojo team. And we also have a StarNet DevNet, which is maintained by Spaceshare. This is the most important tool now. snFoundry. In the past, last year or a few months ago, people use a lot of Protostar, but now it has changed to snFoundry, developed by Software Mention. Yeah, they offer unit integration tools and fork tests. Also, we can test with cheat codes. It's gonna be really useful. So if you have experience with Foundry in Solidity, then you can get really familiar with this tool. Build with Rust. So I mean, this tool has been built with Rust, so fast actually. And we have the forge command, the cache command, forge for test runner. The cache is more like a CLI. They have the GitHub and the book. You can see there. Now, yeah, so the idea is always test before deployment. Think twice about upgradable smart contract. We're gonna work with this, the common test with unit integration, and with this one, snFoundry, testing with cheat code. Yeah, that's it. Let's move into the coding. For the coding, we're gonna check. Yeah, you might remember this contract. Have a look there. For this contract, it's our ownable contract. We used it before on lesson 3. We play with this, we deploy it on DevNet, on testnet, but we didn't add any test on it. So, the idea is always to work with testing. So this time I'm gonna show you that testing. In this case, we're gonna use Cairo test. So it means I'm not using a snFoundry now. Otherwise, I have to add here on the dependencies snFoundry. But this time, for this example, I'm just going to show how it's testing with Cairo test. Like you said, like we have to import all of these functions, all of these modules. Here, this is the most important part from StarNet. This deploys is called. It's going to help us to deploy our smart contract on the testing environment. So let's see how it goes. So to do the testing here, we are using only Scarp. After our Scarp build work, we're gonna do the Scarp test. So for this, we have to set up our environment for the testing. We have to add this flag here, these attributes, if you test, and then create a module for testing this test, then import all what you need. And then for our first testing, we have to add this test flag, set up the gas we're going to use, consume, and then we have to give a name to our function. In this case, it's just unit test. The idea of this is just to deploy the smart contract and check if the owner of the smart contract is the one that we want to set up. So for this, for example, we're gonna create our admin address variable. It's gonna be a contract address type, but for this, we're gonna create this file2 value 252 data type because it's in some ways like a string. So we create this, but this is file 252 and this is like a contract address. They are different kind of data type. So we're gonna try to to cast or to convert from field to contract address. So we're gonna try into and then unwrap this value. We can get the conversion from here to contract address. Okay. Then remember, in order to deploy our smart contract, we have to pass all of the input parameters for the constructor function. Remember here, our constructor function here is gonna take self, but what like first parameter is it requires initial owner. So we have to set up who's going to be the owner of the ownable smart contract. So we have to pass this value in our testing. So how do we accomplish this? So we have to create an array of data. So it's going to be our first value is going to be the contract address of the admin. So it's here. If our constructor needs two more values, we have to add, we can add here like this, but in this case we don't need it. We just need one. But yeah, always we have to pass like an array, and we're gonna call it call data, and mimic the call data. Okay, we already have these two values, variables. Now we can call the both this deploy syscall. So for this, it requires like four parameters. The first one is gonna be the class hash of our smart contract. So we're gonna set up like, ownable, so our smart contract. Then we set up like a class hash. It is a test class hash, so we just call it. It's just like a value there. We don't need to worry too much about it. It's for testing. Try int and wrap, and then we have to add like a solve value for randomness. You can change here. So zero is okay. Then we have to pass the call data, the input parameters. In this case, is same, but it should be like a spawn. So it means it's read only. This data is read only. We cannot change it. This. Then we add this flag like false. And so if you want to check more about deploy syscall, you can check the documentation here. Syscalls here in the standard documentation. They have this deploy, and they also explain about deploy syscall. For example, deploy from zero. What does it mean? So it means a flag used for the contract address computation. If not set, the caller address will be used as the new contract deployer address. Otherwise, zero. Oh, yeah. That's it. Then we're gonna return values. We're gonna get the address of the deployed contract. That's what we want. And the second element is the response away from the contract's construction. I can process span, but this one we don't need it. We only need this for our example. So let's go back there. That's why here we just fetch the first value, and the second we just say, okay, we don't need the second value. So yeah, this is gonna be the address of our deployed smart contract. So after that, remember, we have to create the dispatcher. So to create the dispatcher, we have to pass the contract address. It's gonna be our smart contract. We have the dispatcher now working here. And now we can access to the functions that we define in our smart contract. So we can do this, read owner. So we can check who is the owner here. And we're gonna assert, we're gonna check if our owner in the smart contract is actually the admin address that we define, that we set up here. So yeah, that's it. It's like a very small unit test, but useful. So if you're using a scarp and you try to work on this way, here is to run the test, maybe scarp test, and it's working. What happened if I change it? Yeah, it's failing because actually now I unfix it, so it's gonna work again. So yeah, so this is one way how to test our program, our smart contract. For sure, this is only one unit test. For sure, we want to add more testing here. We're gonna show them later, but this is the very basic one. Yeah, that's it. After this, we're gonna show the Foundry, how we can use a standard Foundry with this. Because actually, most of the people, they suggest to use standard Foundry instead of this like traditional way. Like, yeah, you can find the standard Foundry more useful. They have like you can do any kind of testing there. Maybe here is a bit limited, but it's still working. So let's move into the another example where we can use Starnet Foundry. But first, I want to check the repo Foundry. Starnet Foundry just now they released a new version with 0.13 compilation. They are using 2. Yeah, because just now they just released. There is a new version of Scarp and also for the StarNet 2.4. They released this version, but we're gonna still working with this 12 because sometimes we have to wait a bit more for new releases. So that's why on this video, we're gonna still working with the version number 12. And yeah, let's check here. So this is like the GitHub repository. So they show you here how to build your test with snFoundry. What is the installation? So in your case, you have to follow these rules. Since they just have this new release here, still we have to install the version 12. Yeah, remember? So we have to do this. Okay, we have to press this in our terminal. Then we can do Foundry app, but in our case, we're gonna install. If we do Foundry app, we're gonna get the version 13. So in our case, we're gonna use this second option, Foundry app, and then 12 here. So let's do it. 12. Yeah. Okay. Great. Let's open one more time. Let's see what version we have towards. Okay, we have this version, so it's okay. Yeah, so it's okay. Yeah, like I say, check with this command what version do you have. You can check more there. They also have the book, but remember always to check. Sometimes it's not easy to keep the same piece on the book on the GitHub repo, so it means maybe there are some parts of the book where the team is still working, updating the content of the book, because these tools change a lot so fast. So yeah, always be aware about it carefully. So how to use this? I show you. We have to install snFoundry and then after we install, what we can do is we can add like a dependency of this in our Scarp project. So I'm gonna show you my Scarp project. I have this project. It's only the Scarp, you will see. But here this time I'm gonna add this Forge. So I'm gonna add the snFoundry dependency here. And also I have to specify it's gonna be the 12, the version 12. So good. And for the StarNet, we're still using this 2.3.1, but yeah, they just few days ago so they released that 2.4, the version 13. But from this lesson, we're gonna still working on with this. So yeah, so this is our voting example. So we're gonna check quickly. So the idea is like one contract, one address, one user can vote for 0 or for 1, for yes or for not, and it can only vote one time. It's not allowed to vote 2 times or 3 times, only one time. We have to count this, how many votings are on each side. So that's the general idea. So for this, we have to, always to create our interface, our smart contract. So we have this like a vote. So with this vote, we have ref cells. So it means we're gonna mutate the the contract state. When we do the voting, we have to pass the value if we vote for 0 or for 1. So this is like the writing function, and the reading function or the view function. This one, we are gonna read the contract state. It's read only. That's why we have the snapshot here. We're gonna return how many votes with 0, how many votes with 1. That's it. After we define our interface, we have to define our contract itself. So we create our module. It's gonna be voting contract in our case. Yeah, we define our storage. We define how many votes for yes, how many votes for no, the voters. In this case, we use here a file 252, but up to you. You can change it to U64. Okay, but for example, we keep like this. Then we have these voters. So it's going to help us to do the mapping. We're going to map a user or a user contract, a user address. We want to map it with a bool value. So it's going to be false or a true. So if it's false, it means like the user haven't voted yet. If it is true, it means the user already voted. So it's going to help us to check. Yeah, for later. We define our storage, and then yeah, we are gonna implement our interfaces. So implement our interface for voting contract. So for the vote, yeah, we have to pass a mutable reference for our state. But first, we're gonna check what is the input. The input must be 0 or 1. Then we have to call the caller. So the caller of this smart contract of this function. And then we have to read if this caller or if this user has already bought or not. We're going to check here, for example, self is going to be our contract state. And then voters here, yes, we're in our storage. Voter is here, and then we're going to read the first value of the mapping. So for this, we're going to pass the caller contract address. If it is the first time, the returning value is going to be false. So all of this is going to be false, false, and false. So it's going to become like false time false. It's going to become true. False of false is true. So the third is going to work here in case the caller haven't bought yet. Okay, now we're going to check if it is 0. We're going to add one value on the no votes, votes for no. So we're going to read the previous value and just add +1. Same for 1. If you vote for 1, we have to go to the yes votes, like here, yes vote, and change the value. We're going to change it. We're going to add one to the previous value. So yeah, that's it. After it's done, we're gonna set up this caller has already bought. We're gonna go to voters, this mapping. We're gonna pass the caller address. The bool value in this case is gonna be true. So later this voter, this user cannot vote one more time. In case we want to get the votes, first we're gonna pass how many no votes we have and how many yes votes we have. This is the way. Yes, quite simple now, because the idea is just to show the testing. So this is for our basic concept of our smart contract. And now we go to the testing file. Check here. I have my logic, the logic of my smart contract on this file. But for the testing, I create a new folder and I create this test contract.cairo file. Now we're gonna check how is the sequence to work with this. Remember, we'll have to import everything, not everything, but all what we need from our case. Here we can call this SNG4 std. So it's the same name like our forge here, our snFoundry. We have to import this declare, contract class, start parent, cheat, targets. Remember, here we're gonna go here first, and then we're gonna check one by one. So we're gonna check if the counter of the votes is changing or not. We're gonna test if really the votes counter is changing or not. This is the goal of this testing. So remember, before to do everything, we have to deploy our smart contract. So that's why we have to build by our own more deploy contract function. We have to pass the address. Yeah? So here, we're gonna move from here. This is the deploy contract. We have to build by ourselves. So this is gonna get L252 name. So here inside they call declare. So it means we're gonna declare our smart contract. We're gonna pass the name. The name is of our smart contract is voting contract. So we're gonna declare it here, our voting contract, and we're gonna get the contract here. With this value, we can deploy our contract. We are gonna get the contract address. So how do we deploy? First, remember, first we declare. This declare is already built it on the snFoundry. After that, we deploy it. So we have to pass the data, the input value of our constructor. But in this example, we don't have a constructor or we don't have inputs for our constructor. So it's going to be empty. Array of values, snapshot, but empty. After that, we deploy, it's going to return a contract address. That's why we don't have this, because the returned value is going to go to here. Great. So let's recover here. We pass the name of our smart contract, and then we get the contract address on this part. Yeah. Now, second, we have the expected votes values. So it's also a helper function. Here we have to pass the contract address and these two values. So let's check here. Expected both contract values on this part. So here, yeah, first input parameter is the contract address, and then we have to pass the expected no votes and expected yes votes. On this part, once we already have the deployed contract address, we can easily build a dispatcher. So we build our dispatcher here. We just pass the contract address. We have the dispatcher, so now we can read the values. So get both, we're gonna get both. Remember, get both is gonna give us it's gonna return the number, the counter, the number of no balls, the number of yes balls. So after we deploy our smart contract, we have to check if the no balls from the smart contracts is the same, like it's the same value as the one that we expected. So we have to pass this to assert. So yeah, remember when we just deployed the smart contract, all of the values they are like default values, so they must be 0. So that's why we do this. We check here if they are 0 or not. So they might pass here. They might pass this assert. Okay, if it is working, let's continue. Let's move on. And now after this, we're gonna call our dispatcher again. And in this case, we're gonna vote. We're gonna vote, and we're gonna set up 1 here. So remember, when we vote, we can vote only for 0 or for 1. In this case, we're voting for 1. 1 is gonna mean vote for 1. It's gonna mean yes. Yeah, 1 is yes. So remember here, when we pass these values, first we have to pass the number of no votes and the number of yes votes. In this case, we vote for yes, so we add 1 here. Yes, so it might work. Let's try it. Let's try how it goes. Yeah, in this case, I'm running all the functions, but yeah, one of them is test both counter chain. Yeah, test both counter chain. It passed, so it means all of this is working as we expected. Oh yeah, that's great. It's good. After that, we can move to the next example of the test. We're going to test voting multiple times from different accounts. Yeah, something similar. We have to deploy our contract. We're going to pass the name of the smart contract. We're going to get the contract address. And then similar, we have to check this. We are starting from 0 or not. They might be the default values. If it's okay, then we can vote. So here now we have this new helper function. It's gonna be vote with caller address. Is here the full definition. So this time, yeah, we have to pass the contract address, the contract of the deployed smart contract, and the prank address and the value. Here they call it prank address because it's part of the vocabulary they use on Foundry. So actually it means we can set up like the owner of the address or the caller of this function. It can be any address. So because we are testing, we can set up the caller of the function. It's gonna be this address or another address. So yeah, that's why. But on this context, they call it like a bracket address. And here, let's see, for example, yeah, both with caller address. So we have to pass the caller address. That's gonna be this one. So when we are in this function, we have to start this start prank. So start prank is like a cheat code within the snFoundry tool. So it means we're gonna set up the caller of this function is gonna be this bracket address. For that, we have to pass this contract address here on this format. Cheat target 1, and then here we have to pass the contract address, and then our caller address is gonna be the prank. So from here, the new caller of this function is gonna be this address. And then dispatcher, and then we vote with the value we pass. So just like this. If you want to check more about what is a star rank, here, like they say, they have the book. We can choose using cheat codes. They have some examples. Here, they also talk about a star prank. So this we can trade various properties of the transaction. Yeah. For this case, star prank should come. It's gonna train the caller address, so it passes our validation. Yeah, you can trade these examples here. Also, stop prank. So yeah, we're gonna stop during. So that caller is not gonna be the caller anymore. They have a lot of cheat codes. You can check there. But let's see how to use it. So remember, this is our smart contract address. This is caller address. So now prank is useful because for this time, for this function, the caller address is 101. For the next one, the new caller address is 102. And for this one, the new caller address is 103. So yeah, that's how it works. Check here, balls for one. We have 2 balls for one and 3 balls for zero. Remember, zero is no votes. No votes is the first. Yes votes is later. So we must have 3 no votes and two yes votes. That's how our expected votes counter values is gonna work. So let's do it one more time. And then yeah, we have this test voting multiple times, test voting multiple times. It has passed. So all of this is working. That's good. Lastly, we have this testing test voting twice from same account. Yeah, the idea is to always avoid that some address or some user that already have votes, they cannot vote anymore. So we also have to test this functionality. So how do we do here is, again, we have to deploy our smart contract. In this case, we just write the prank here. So remember, we have to pass the contract address on this format, which is added. And then this is gonna be the address of our new caller or pranked address, or pranked caller. So this is gonna be the address. Yeah, we have to format in order to receive this, in order to start prank. It's gonna work. After that, we have to create our dispatcher. But in this case, it's gonna be a safe dispatcher. You can check more also about safe dispatcher here. Here, about safe dispatcher testing. Yeah, good. So it means like we can use safe dispatcher when we try to do this, when we try to test something with panic. Here you can see panic here. So they say using this safe dispatcher, we can test that the function in fact panics with unexpected message. Yeah, so that's what we try to accomplish. That's why we use this time safe dispatcher. So safe dispatcher is gonna vote one for one, and this time we have to unwrap as well. Okay, when we do this, we have to match. Yeah, match dispatcher. So in this case, remember it's already have vote one. So now they try to vote for zero. So what's gonna happen? So it might return. So if it is okay, it should panic. Let's say if it is error, we have to assert here the panic data. Panic data at zero, and then you have already bought panic data. So at the end, this is gonna panic, yeah? Because remember, we already bought for one. We cannot vote for zero. So anyway, it's gonna panic. So, but here the match is handling all of this panic situation. So it means our smart contract must work because we are handling this like a panic case. So that's why it's working. Yeah, maybe it might look a bit complicated, but the idea is always to check now. If it is okay, it's not gonna be okay, yeah? So it's not gonna be okay. If it is okay, we should return this, should panic. It's not, why it's not gonna be okay? Because we already bought, so we cannot vote one more time. But in case, if it is okay, we should panic. So in this case, what's gonna really happen is gonna go error, yeah? When we do this, after that, it's gonna come here to panic the error, and we are gonna serve this panic. We're gonna handle this situation, so that's why the test pass. Yeah, that's it. That's it. Actually, snFoundry is a really great tool. They are working very hard, and I can see it's improving a lot, a lot, a lot. So there is always something to check there. That's it for testing. Actually, I'm going to talk about the homework here. The homework here is to implement the test for our ownable example. Remember our ownable example from just a few minutes ago? We talked about ownable example. We showed this testing with Cairo test, but in this case, the homework is to add here, we have to add here the snFoundry and build two or three tests. I want to check later how many tests. So we have to build three tests in our new file. We have to use snFoundry for this example. So yeah, that's gonna be the homework. I'm gonna show the details later. So this is for testing. After this, we're gonna talk about different topic. We're gonna talk about components. Maybe you heard about components before this section. So yeah, in a while, let's continue with components. Okay. Like an intro, we're gonna talk about components. Components is a new concept here, at least on Starnet, smart contracts here. Is the Starnet 2.3, the 2.3 version, like 1 month ago, 2 months ago at least. Yeah, between 1 and 2 months ago, they introduced components here on the smart contracts. Actually, it is still quite new, but I think it's worth it to talk about it. So I think from next year, most of the smart contracts, they're going to include these components on their implementation. So it's going to be good for all of us to know more about components. So what's the idea of all of this? Well, now I'm on the Cairo book. You can check the Cairo book. It's also a good resource for learning about Starnet and Cairo. This you can check all of this by your own. But I'm on this part because we already talked about smart contract, this, but we didn't talk about components. So what's components? They say Lego like building blocks for a smart contract. So let's read quickly this. Developing contracts, sharing a common logic and storage can be painful and book from, and this logic can hardly be reduced and needs to be implemented in each contract. But what if there was a way to snap just the extra functionality you need inside your contract, separating the core logic of your contract from the rest. Here, components provide that. They are modular, adds-on, encapsulating reusable logic, storage events that can be incorporated into multiple contracts. This can be used to extend contracts functionality without having to implement the same logic over and over again. So, in your whole project, you can have many smart contracts. In one project, you can have like 6, 7, 10 smart contracts. Now with components, you can reuse some pieces, maybe 2 or 3 smart contracts share the same implementation. Components is going to help us to reuse this implementation between these contracts inside of our project. So that's it. They say think of components as Lego blocks. They allow you to enrich your contract by plugging in a module that you or someone else wrote. This model can be implemented one like a component or more complex like ERC20 token full-fledged. A component is a separate module, so it means when we are doing the coding, we have to create a new module for the component. So that can contain storage, event, and functions. So this is going to be inside our component: storage, events, and functions. Unlike a contract itself, a component cannot be declared or deployed. Its logic will be eventually part of the contracts by code. It has been so yeah, we're gonna deploy the contract, but our contract is gonna integrate the component logic there. Here, one more time. So a component is very similar to contract. It contains storage variables, event, and function. One more time, component cannot be deployed on its own. The component's code becomes part of the contract. So there, they show example similar to our contract where you have to work with that. But here I'm gonna show my ownable contract example. See, yeah, we're gonna use this drive. We're gonna use this, and then I have to open my other. Okay, now the idea for now is we are going to refactor this our ownable contract. We talk a lot about it. We implement it on this way, but now we're going to refactor our smart contract in order to use components. So how it's going to work? Remember, here we have 2 interfaces here. One is related with data, and the other one is related with the ownable trait. So thinking about with component and smart contract, it's easy to take to refactor this like a trait or interface, like an interface for a component, not for the smart contract. So it means our smart contract is gonna handle this, and our component is gonna handle this. So maybe we have more smart contracts here. All of them, they can call the component for the ownable of the or the ownership logic. So yeah, that's the idea. Remember, for this example, so that's the idea to move from this implementation to the component implementation. Remember, this is still the previous example. It's not a new example, but I just want to show you what is our strategy. Since we already have two interfaces, one of them is going to become part of the components, and this is going to be this on our interface. So remember, our storage has the data, yeah? I mean, have the fields for data and owner. So in the new example, this owner field is going to be part of the component, not part of the component, and then we can call here inside the storage. We're going to see later. Same every time we want to call the owner, we have to call the storage of the component, and then we call the owner. You're going to see the difference later on this part. Same on the implementation. This is going to be almost same because we're going to keep this because everything related with data is going to be on the smart contract. So this is going to be all the same. But for this part, we're going to here, especially in this part, we're going to call different attributes, labels, more traits in order to implement this on component. Right now, it's still it's still part of the contract module on the owner. And yeah, that's it. That's it. So let's start doing the refactoring. I already work on this, so I'm gonna show you. Hope you guys can see it. Great. In order to make it easy, actually, I'm not gonna implement this for data. Just get data and set data. I have this interface. You see, it's the same. And then I also have my interface. Ownable is actually the same. Ownable train, the same. Transfer ownership, read owner, same. And here, remember, this is the previous example. We have the contract, but in this new example for this lesson, we want to work with components. So now, first we have to define the component, and the component is going to be what? It's going to be this. We have to implement this. So remember, first we have to implement the component. Like they say, we have to create a module with the name of the component. I call it ownable component, and yeah, we have to add this attribute here, component. And then remember, the component is going to have its own storage. So it's their own storage, and only it's going to contain the data related with the owner or the ownership. In this case, is the contract address. So the owner, good. And then events about the transfer, what to transfer the ownership. Same. This is almost similar, like we have here, but in this case, it's inside the component. Let me show you here. Yeah. You can see it's pretty the same, but the difference is now events, this kind of event is inside a module of component, but before it was in the contract side, inside the contract. Now the implementation. Oh yeah, I'm gonna open. For the implementation, yeah, we have these functions, but here now this is something new. We have to ask like invisible as ownable in this case. And then we have to call all of these. It looks, like a bit messy with a lot of code here. You can see maybe it's easy to keep in the previous version, but yeah, actually components is a really great feature. Although maybe in the future, the star netting can work in order to make it more friendly, yeah? More like a developer friendly. For now, it's a lot of code here in order to implement the function for the components. Or in this case, yeah, we have to create our ownable implementation. We have to call that contract state. Also, this is new, has component. We have to add the has component and the contract state here. The implementation of what? Ownable interface, that is this, okay? But we have to pass the component state in this case and the contract state. So yeah, a lot of code here, but that's it. After that, yeah, we can implement our transfer ownership and our read owner. It might be similar here, yeah? Yeah, something similar. The transfer ownership, only owner. In this case, I just created one more function, transfer ownership, but it's gonna be almost same like this. Let's check later. And then owner or read owner is the same. So here, check. So this function is not on the interface here. So it means it's like kind of internal function. That's why I have to implement this here below. To accomplish that, again, I have to create a generate trait for internal function, similar like in the previous example for the private methods. It looks more simple in this case, but now we're talking about components. In components, remember you have to add all of these, all of this piece of code, and after that you can build your internal function. Here we build the only owner. It's almost saying like this only owner. But remember, every time you have to call, in this case, a self-component state. It's different from self-contract state because now we are in the component context there. So we call a snapshot of the component state with the contract state here. Yeah, that's it. You can check more here. For the transfer ownership, yes, almost same. We have to call our owner, write the new owner on the owner field, init the event. So yeah, that's it. So the idea is to get familiar with this style of implementation for component, this style of implementation for components. We cover almost everything here. How to declare the interface of the component is pretty the same like for contracts. We have to create storage, the events, implement the external function and the private function. So that's it. So let's continue here. Yeah, after we defined our component, we can build our smart contract itself. So now our smart contract is, you can see, it's smaller than this example because yeah, we have created first our component, different module. So on this module, we have to now start working on the smart contract itself. We call the attribute external contract. We create ownable contract, ownable project. From our ownable project is here. Yeah? It's my scarf. One of these is my scarf here. I have to call the ownable component. So I have to import the module here because it is another module here. Ownable component. I have to import the ownable component here. And then yeah, I have to add all of this is also new. I have to set up, I have to call this macro. So on this macro, I have to pass the path of the owner of the component. In this case, it's ownable component like this. Problem. I have to set up like a storage. So it means what's the name of what's going to be the name of the storage on the component inside our smart contract. So it's going to be ownable. So here it has ownable event, ownable event. Here I have my ownable event, and that's it. And then I just have to call this the implementation. Yeah, implementation of my ownable components and also implementation of the internal functions. So yeah, in this case, you just try to set up according to your use case to make it work components inside your smart contract. After that, we have to build our storage. In this case, our smart contract, the logic, the main logic, the functionality of our smart contract is going to be more based on data. So the component is going to be in charge of the ownable part. So that's why this data is the field or our smart contract. And then we have a super storage. This super storage is going to be actually the storage of our component. And we're going to call it ownable. In this case, like we say here, ownable. But what is this? It's going to be the, remember, ownable component storage, the storage or our ownable component. So we are linked. We have to link here. We have to link our component with our contract. That's why it's like this. Okay, after that, we can create our, oh yeah, I have our ownable event here, almost same. We have to create an event, but it might be like the ownable event from the component. So that's why here we just call the event from ownable component on this event here in our smart contract, right? In order to the constructor, remember the constructor is going to handle the storage, but the storage has two fields here. One field for data and one field for the component, component storage. That's why, for example, here we just define contract state, contract address, good. If I want to work with data, I call self data, write one. But if I want to call with ownable, it's going to be like this. Self ownable is this name. And then I have to go to owner. What is owner? owner is the field inside the storage ownable component. Let's find it. Here, you see, owner. So if I want to access this owner, first I have to access this, the storage, the ownable here that I'm on the storage of the component, and then I can access to this owner. So that's why it's a bit longer now. Self ownable. This is the field on the smart contract. This is the field on the component. I have I can write it now. I can pass initial owner. So it's different, yeah, like the constructor we have here. It's a bit different. You can check. And for get data, yeah, it's almost same. And for set data, I have to do also that here in this case, let's check set data. Self, in this case self, but I have to access to the storage of the component. That's where I go to ownable, only owner. Before, don't need to do that. But now, yeah, we have to access there. And yeah, that's it. That's it. Let's check if it is working or not. Car field is working. You also can play with this testing and deploy it. At least we on one, you can deploy it on testnet. You can use any of your Argent or your Bravos wallet and play with it and check if it is really working or not. I did it on my side, but yeah, it can be a homework for you as well. Let's think about it. But yeah, I think yeah, that's all for components on this example. After this, we're going to talk a bit more components on ERC20, ERC721 examples. We can check the open sampling examples. They use components. That's why I'm trying to do the introduction to components here now. So let's check now the open sampling examples with components on ERC20. On this part, we're going to talk about contracts on Cairo. Basically, we're going to talk about ERC20 and ERC21. So yeah, this is for tokens and NFT, you might know. So we're going to check the examples of the reference. We found it on OpenSampling. Like you might know, OpenSampling is like one of the best thing if we talk about a smart contract, especially about DeFi or or related to tokens. They are really famous, especially on the Ethereum Solidity community. But now they also have this kind of implementation, like they say. They have this implementation written in Cairo for Starnet. So that's good for us. So that's the idea to check this. Let's go to this part, to the token. So here they talk about ERC20. Let's see, ERC20 token standard is a specification for fungible token, a time token where all the units are exactly equal to each other. So yeah, okay, ERC20 components here provides an approximation of EIP20 in Cairo. So what does it mean? EIP, like you might know, is like Ethereum improvement proposals. So for the Ethereum community, they have a lot of EIP proposals to improve the blockchain itself. So ERC20 was introduced in 2015, so it has been a long time. So basically, they set up a list of functions that we must to implement or take it in order to use a token standard. So yeah, we have this name, function symbol, transfer, allowance, and all of this. Good, but this is more for the Ethereum. So like they say, now on OpenSampling, we can find the implementation in Cairo for a Starnet. So like they say, it's just approximation of this, but of the EIP20, but this is still quite good. So let's check the interface. You can see the following interface represents the full API of the contract. ERC20 component. The interface includes the interface ERC20 standard as well as non-standard as increase allowance. Yeah. For all the tokens. As mentioned in dual interfaces. Yeah, dual interfaces, it means like, yeah, it can support camel case and snake case when we call some functions like this one or this one. So you can see for this ERC20 API, we have to implement like a trade. It has all of these functions: total supply, balance, transfer, name. This is for the ERC20 itself. This is for the metadata, name, symbol, decimals. For the safe allowance, increase and decrease. This is for the camel case. They have this total supply, but they have also this snake case. So both implementations, they are the same. Just, the name of the function is slightly different because of snake and camel case. Same here. Yes, same here. Here they also talk about, although StarNet is not EVM compatible, StarNet is not an EVM, so that's why we have, the StarNet ecosystem with different language like Cairo. This component aims to be as close as possible to the ERC20 token standard. So it's component. So it means, remember, before we talk about component, so now when we are going to work with ERC20, it's going to be a component here, ERC20 component, here ERC20 component. So in this case, ERC20 is not going to be a smart contract, is going to be a component. So how we can use it? In this case, they show this using contract for Cairo, because constructing an ERC20 contract requires setting up the constructor and instating the token implementation. Because this is how it looks like. So we have to create our smart contract with this attribute. It can be called my token. So here we have to import the ERC20 component. So we don't have to build by ourselves because OpenZeppelin provides this ERC20 component. So we just have to import, and then we have to define, like before, we have to define the component macro. The path is going to be this ERC20 component. Storage is going to be the ERC20 storage on the component. Event is going to be the ERC20 event on the component. That's good. And then we have to get the implementation. For this ERC20 implementation, ERC20 metadata implementation, common only, internal. Then, in this case, for this smart contract, this is the storage, and the storage only has field from the component. That's why we only got this one, the ERC20 component storage. So in this case, it's going to be the same, the storage of the smart contract and the storage of the component. For event, we can declare like this, event ERC20, but it's going to be for ERC20 component, and easily we can get this, the constructor. We have to pass the contract state, initial supply, in order to mint our token, contract receipt, in order to mint as well. And then we have to initialize our token. We have to pass the name of the symbol. And that's it. And then you can customize according to your own use case. That's pretty much. Check on the GitHub. They also have something like the instructions. We have to find, in this case, maybe Rust, the Cairo contracts. Here they also explain about it. So we can follow this instruction in order to create our project. So we just have to add the dependency here, like before, create it. Use this to create my token. Also for development. We can do the scar build and get the target file. And also we can run scar test. So let's do the second one, since the first one is quite simple. So actually we're gonna get into this, where we can say ERC20 component. We're gonna check that. We can check that. We have to do this git clone, go into the files and build it. And then we can do the testing. So let's try this. Something is wrong here. So let's see. It's not working. Oh because I have to pass the HTML in my case. I have to pass like this. After that, we have to do CD Cairo contracts. Let's open it first. Let's see what is there inside. Okay, we are there. We have to check here, especially components and presets. That's most important folders for us in our case. So like, remember in our example here, they just import this ERC20 component. So we can check what is inside here, because now we just import, we don't know too much about it. But now, since we have access to the OpenZeppelin repository, we can check there. So ERC20 ERC token, we're gonna search for this component, and might be here. We found it. So here we can check more about what is inside the ERC20 component. In the storage, they have to define the name, symbol, total supply, balance, and allowance. See, for balance, they have this. They are going to map to a contract address with U256 value. And for legacy map, they use this kind of tuple for allowance. In allowance, we have to set up how much money the owner allowed the sender to spend it. So is it? And they have this event. We define the event here for transfers and approval. We define the transfer event, then the approval event. We have the errors here. And this is a bit more interesting. We have the total supply, but you can see here they use embeddable as ERC20 implementation. So they are implementing the functions for the components, write the code IDs, have to pass the context state that has components, context state here of this interface. So we're implementing this interface. Let's check here ERC20 interface. Here ERC20 interface. Maybe here. So here they only have the interface. There is no implementation. So here we implement it. We just import the interface from there. Yeah, import from there, and then we can implement it with total supply, balance of allowance. So it's pretty the same like for Solidity, transfer from, approve, same for the metadata, the name, symbol, decimals. Yeah, that's it. And then they're going to repeat, but in the camel case, but the implementation is going to be almost the same. And yeah, that's it for the ERC20. We also have the presets here. Presets. We're going to check here what does it mean, presets. Here we have presets. So it means list of ready to deploy preset availables and the corresponding class hashes. Yeah, you can check all of these class hash in order to work with any of these these two token or accounts. So that's it. We're going to check here preset. What do we have? ERC20 preset. ERC20 preset offers basically functionality and provides a fixed supply mechanism. So it depends. Most of the time, sometimes it's fixed supply, sometimes it can be dynamic. As here they say fixed supply for token distribution. The fixed supply is set in the constructor. Okay, great. Remembering here, they just import the ERC20 component. It's pretty same like the example on the GitHub. Define the event, define the storage, they have fixed supply on the constructor. This same value fixed supply is gonna be minted with this internal mint. You can see this underscore. So it means it's like an internal mint. It's not exposed. It's not public or external. So we can call it just that's it. We just can call it inside of our smart contract. And yeah, this could be your template if you want to start working with ERC20. Just go to the presets and you can customize it according to your use case. So the same happens for ERC20 ERC721. In this case, we have to import the ERC21 component and also this RC5 component. This is out of the scope, but you can check it later. So most of the time, we use the ERC20 component. All of these implementation, metadata, camel only, metadata with camel only. Since we still have to handle this both cases, camel case and state case, so we have to implement all of these. But actually, we are just importing from the component itself. Same here for the API, SRC5. In this case, we have two storage, two components, one component for the ERC21 and one component for the SRC5. Same here, our events, our constructor. We're going to mint the assets. In this case, we have URIs here. If you have worked with NFT before, we have to handle URIs. So says the token jury from token juries to the corresponding token ID. Okay. And then we have this mint asset. It's like internal function private. This is implementation for this. They use more internal functions. And that's it. What is interesting here, we have this test. For example, how do they test all of this code? So we can run a scarp test, like we mentioned before. They are going to test all of these modules. But remember, they use scarp 2.3. Let's see. we have to run scarf test, but in the overview, we can see they use this version of the scarf. So it's the same version, it might be the same version as you might have in your own local machine. Otherwise, try to downgrade this version because right now it's 2.4, the latest version. And yeah, oh, we got all of these tests passed. There is a lot of tests, but we don't need it all of them. We can just set up some tests for us. For example, we don't need this. Maybe we need that one. Let's say security. We don't need this. We don't need this. We don't need this. I think we need accounts. Let's see. One more time. Start test, but it might be less tests. The number of tests must be smaller than before because we just want to test some functionality, not all of them. Okay, that's good. The most important ones are token. We used to test the token and the presets, but it also includes the utils, mocks, and accounts. Let's try. Account is maybe we don't need it. If we got the error, we have to change it. Yeah, because of the account. Yeah. We cannot read the count. So yeah, one more time. Okay, we got all of these kind of different tests. We're gonna check some of them. Like 400 is still too much. Like I said, we have to go to this file test. We can check the presets. We can check this, the ERC20. How do they do the testing? So in this case, this is just the helper functions. Test start here, but it's gonna be important these two. So first, in this case, they set up the dispatcher. But remember, we just been talking about tests before. In this case, they don't use you see, they don't use the snFoundry. They just use the Cairo testing. So it's gonna be a bit different from what we saw before. Still fine, it's working, so no problem. So this is how they work here. They have this setup dispatcher. So what's it gonna do is with event. In this case, with when we set up the dispatcher, we have to create a call data with all the input parameters. We have the name, the symbol, the supply, and the owner. All of this is their constant values. They are here in constant, so we have to go to utils, then access selectors, the open zeppelin test. Oh, they are inside of test, so they might be here. There's util constant here. So this value is going to be the same along across all the tests. That's why they set up a constant file. Okay. As you can see, yeah, this name value is going to be name, same symbol, supply, owner, so which one is. You can change here according to your use case, so no problem in that. After we got the values for call data, we call deploy. So it's gonna deploy our smart contract. So we can also check what's here inside of deployed. They call it from utils, and utils might be from tests. So we can check here utils. Let's deploy. What is this? Let me check here. Deploy. It's here. Oh, yeah, it's here. Let's put it here. Okay. Remember, they are calling this deploy. So it's almost saying like, so you might remember this deploy syscall. We saw it before. So actually, they are like wrapping this deploy syscall. They just have to pass the contract class hash and the call data. Since the salt is going to be almost saying 0, this flag is going to be false. We can set up this helper function. It's going to help a lot. Yeah, we just pass the class hash. That is a fixed value as well. And the call data. And then we deploy and we get our address of our smart contract deployed address. And we create a dispatcher and we return the dispatcher with this. That's why they do it here when they test the constructor. Dispatcher is here and they are going to check if everything here, they're going to check is, yeah, if name is the same like this name here, symbol, owner, all of them. Yeah, at the end, this is only for the test constructor, but they have for everything. for the total supply, for the balance, or for the test allowance. Yeah, you can see there are a lot of testing. So yeah, like I said, you can play with them, and you can take them like a reference when you want to build your, your own project, and you want to add ERC20 or ERC721 implementation. You can just call the presets here, and you can build your project. And if you want to know more about the details of this, just check the tests here and also check the implementation of the token. You can check that implementation of the token here. They have also implementation. Yeah, it's a lot of code, but yeah, is it? That's it. So that's about actually the ERC20 and ERC721 implementation. Just try to play with this. But remember, yeah, this is like a template, the presets. But remember always, so you have to add this like open setting dependency on your start file, and you have to set up the version of this. Yeah, yeah. Like I mentioned before, today we talk about component and testing. So yeah, this is the best example for component plus testing because like we mentioned, ERC20 implementation on OpenZeppelin, they use component. So yeah, it's a great example to check, to analyze, and to see how it works. The idea is, like I mentioned, just try to use the preset and work in your own project. Okay, that's all for this lesson. See you next time.